So today we're going to be looking at solving for all solutions of theta. Specifically, we'll be looking at three different approaches for solving sine of theta equals 1/2 as an example case. If we remember, right, our trigonometric relationships, we input an angle and it outputs a ratio of sides. But then last class, when we developed our inverse trig, we were able to take the ratio of sides as our input and then get that angle as an output. So we're going to look at how a little more in depth at how this solving works. So we're going to approach it a couple different ways. Table 1, if you could go ahead and solve by graphing using the line y equals 1/2 and the curve y equals sine of theta and looking for those intersections. Table 2, you'll solve using our unit circles that we have from last class. And table 3, you're going to use that inverse trig function on your calculator to get an answer. Great. So what do we get, table 1? Right? So our first step is we get the sine of theta graph. And then we're going to put the line y equals 1/2 in through here. And we're going to look for those intersections. If we use our calculate intersection function on our calculator, we'll get that this value is equal to 0.52 or approximately pi/6, right? And we're going to have this whole list of solutions that we can go through, find one by one. Awesome. When we're using the unit circle, right, we'll have our circle here. And remember, our sine value is that y coordinate, right? So we'll come up to 1/2 right here on our y-axis, draw this out and find those couple possible solutions. Right, and we're going to have this first solution, right? That's going to be theta 1, which is going to be equal to pi/6. And then also we'll have another solution over here, right? Theta 2 will be the angle we get there, which is equal to 5 pi/6. Right, so these are those two unique solutions we're going to have in the unit circle, right? And then if we solve using our calculator, we'll take the inverse sine of 1/2. And that's going to output 0.52 or pi/6, right? We'll get it as that decimal from our calculator. So this leads me to ask this question, right? How many solutions do we have? How many solutions did each of your groups get? Yeah, right? So table 3 had 1 solution. Table 2 had 2 solutions. And table 1 had an infinite number of solutions because these are going to keep repeating forever. So what's going on here? What questions is this popping up for you about how many solutions do we have for theta when we have it equaling a ratio of sides? Awesome. Is there a pattern? Pattern. Right? Are they all unique? How do we solve for multiples? Awesome. Great, so if we take a look here, right, what relationship do we have between this theta and this one, right? Yeah, those are going to be our first ones. Those are our same solutions. And so then here, this solution, trying to go red, this solution is going to relate to this theta 2, right? This is our theta 2 at 5 pi/6. But then, what's our relationship between this first solution and this solution on the way up that curve again? Or this next one over here? Yeah, it's just a whole period forward. We can see that on our curve or just by rotating around. We're going to get that solution again as we do more and more laps around our unit circle. So ultimately, we have these two unique solutions that are repeated infinitely, but our calculator only gives us one because of that restricted range. So now we need to look at how are we going to solve for these multiples, right? So as a table, either use the graph of sine of theta or the unit circle to try to come up with a way to find our second unique solution. So if we're looking at the graph of sine of theta, make that really nice. Great. Right, so remember this intersection, this is pi, comma 0. Right here is 0, comma 0. And if we put that 1/2 across, right, we're going to notice that this distance right here is going to be equal to this distance right there. So we can say that theta 2 is equal to pi minus theta 1, right? And then if we approach this with our unit circle, like we did in the page before, we're going to have our theta 1 and our theta 2. And we're going to notice that these two angles are supplementary. So theta 2 plus theta 1 is equal to pi radians. We do a little algebra, and we end up with theta 2 is equal to pi minus theta 1. So once again, right, we have the same formula showing up the two different ways we looked at it, right? And then the other analytic way is we know that our identity of sine of pi minus theta is equal to sine of theta. So once again, we see this reappearing one other way. So these are three different solutions or approaches to finding the multiple solutions of sine of theta. Next, we're going to look at finding all of our solutions for cosine of theta and then tangent of theta.